right, so for this lesson, we introduced the idea of a confidence interval, as well as two different types of tests to perform on your GDC to determine the confidence interval. I think one of the best ways of just explaining what a confidence interval is to get to an example question. So we have a biologist studying the population of stag beetles, which we know are normally distributed. And we know the standard deviation of the population. So that's the standard deviation of the population, 2.18 millimeters. However, in a sample, a size of 16, we have the mean length being 35.84 millimeters. Keep in mind, that's the mean of the sample, not the population. In fact, if we look at this, we don't know what the mean of the population is. So the idea is, okay, if we know the standard deviation of the population and we have a sample in which we know the mean of that, what is the mean of the actual population? Well, it's impossible to know exactly what the mean of the population is just from a sample. The larger the sample is, the more valid or the more closely aligned our sample mean approaches the actual mean, but it's impossible to know exactly what it is. The idea is, okay, we don't know exactly what the mean is. It's going to be around 35.84, but what sort of range can we feel 95% confident in that the actual mean of the population is within which values with this certain percentage of confidence? And so to calculate that, it's actually a fairly tedious calculation that we just let our GDC do. But in general, if we have a question like this in which we know the mean of the sample, we know the standard deviation of the population, and we know the sample size, which is 16, we can quite quickly calculate what we believe the mean of the population is within 95% confidence. And so, sorry, someone's at the door distracting me. There we go. So for this sort of question, we want to use a Z test, or Z test, if you want to say that. And in general, anytime we have, or I should say a Z interval test. And in general, anytime we know the standard deviation of the population, we can use a Z interval test. Sometimes we'll see questions where we don't know the standard deviation of the population, but we'll leave that for now. And so in this case, we know the standard deviation of the population, we know the mean of our sample, we know the sample size, we know our confidence level. So we use this test and it should be quite quick. And we should almost right away get a confidence interval of 34.772 to 36.908. Now that's just from our GDC. So what does this mean? This means we can be 95% confident that the actual mean of the population, not the sample, is somewhere between these values. And if we changed this confidence level, for our GDC, if we only put in a 90% confidence level, we can expect a larger interval. If we put in a smaller confidence level, we can expect a smaller interval. And as well, the sample size affects things. In general, the larger the sample size, you can expect your mean to be closer to the actual mean. Either way, all this is very, very quick to calculate. And just keep in mind, if we know the standard deviation of the population, which we do, then we use the Z interval test. Just keep in mind, I haven't quite answered the question yet. It's actually asking for the mean. Sorry, oh no, I'm totally right. Find the length. Oh no, sorry, I'm not right. Double sorry. I want the length of the confidence interval. Sorry, I have the word length here twice. So all that's left is, this is my confidence interval here. I just need the length is just the difference of the largest to the smallest. So it is 36.908 minus 34.772. So we say the length of the interval is just the difference between them to three significant figures, approximately 2.14 millimeters. We should definitely have the units at this point. All right, so that's where we have we actually know the statistics of these things. In this next question, very similar idea. This time, we actually have the sample of 8. These are Christmas beetles. So these are the length, right? Yep, the length of these Christmas beetles. Same type of question. We know the standard deviation of the population is 2.39. So again, that is not of our sample. So we use the Greek letter sigma to denote that. We want a 90% confidence interval this time. It doesn't state what the mean of the sample is, but we can quickly get our GDC to figure it out. So again, this will still be a Z interval test, because again, we know the standard deviation of the population. And this time, same idea as before, but we want to be familiar with our GDC. Instead of typing in the statistics of specifically the mean of the sample and the number and the sample size here, we just type this into our GDC into the table, and then we access it through the test and tell the test that we're using data instead of the stats. And again, you want to be familiar with your GDC. Should be really, really quick though. In this case, we get an interval of 24.612 to 21.833 to 24.612. That's the interval. Again, we want the length of the interval. So I subtract the bigger minus the smallest. So maybe I'll go back to what I was writing at first, because again, we just want the length. And again, to three significant figures, we get about 2.78 millimeters. And remember, again, these are actually really quick questions once we know how to use our GDC. So most important things are knowing how to use our GDC, as well as what we're figuring out. Again, these are our predictions as to what the mean of the actual population is between these values, with a 95% confidence, 90% confidence, depends on the values. All right, so still a question here that's quite similar. This time, what do we have? I'm not going to read it all, but we can see that we have these screws being produced, and the length of the screws is approximately normal, with a variance of 0.5329. And these would be millimeters squared. So keep in mind, that's the variance of the population. So that's denoted like that. We then have a sample of 30 screws, and the mean of the sample is 3079.31. So again, that's our sample mean. So we know the sample mean this time, and we want a 95% confidence interval to determine what is the interval for the mean. Actually, to be honest, we're once again looking for find the length of the confidence interval. Sorry, the word length just keeps popping up in different meanings, and my brain is very confused this morning. So that's it. Let's now again realize, okay, we want to use a Z interval test, because again, we know the standard deviation of the population. And we know that because we know the variance. And so keep in mind, the standard deviation will be the square root of that 0.5329. All right, at this point, same idea. That's our standard deviation. There's our mean highlighted in blue. The sample size is 30. The confidence interval is 95%. Should be very, very quick. We should get an interval, a very small interval, in which the largest value is 79.571 millimeters. The smallest value is 79.049 millimeters. And so the length of our confidence interval is 0.522 millimeters. That is, again, the confidence length, or the length of the confidence interval. All right, so notice I've used the Z interval test a few times. When do we use the other test, a T interval test? A question like this, in which we don't know the standard deviation of the population. So everything's coming from a sample. In this case, we got a bunch of cattle, and these are their mass in kilograms, so 10 cattle. And so we want to determine what is the confidence interval here. The specifics of how the question is written I'll get to in a bit, but really we just want to figure out what's the confidence interval here. And so for this, first thing I got to realize is that, again, I don't know the standard deviation of the population, but I can figure out the standard deviation of the sample, and I can figure out the mean of the sample. So our first task is to put this information into our GDC. As usual, a table. It's not a frequency table, just a single column with these 10 values. We should then, but we know there's a sample of 10. So again, we don't know the standard deviation of the population. And this is why we use the T interval test. be familiar with your GDC, input the information, tell it that you want to run the test based on data, not from the given statistics. You should quickly see that the mean of the sample is 803.7 kilograms. You should quickly see that the standard deviation of the sample, not the population, is about 92.89 kilograms. Keep in mind again, notice I'm not using the lowercase sigma. That's for the population. This is for the sample, and we want to get used to that notation. And we can quickly see that the confidence interval with, 95% confidence, which is pretty standard, is from 737.25 to 870.15. So we can be 95% confident that the mean of the population of the entire herd, not just the sample, is somewhere within there. That said, lastly, the form of the question is written like this. Basically, to figure out how far from the mean is the upper and lower ends, fairly quick to calculate. I need to figure out really just how far is the mean from either end. The mean is right in the middle. So notice if we find the midpoint of here, that will be the mean. So I'll just say the midpoint we've already seen is the same as the mean, which is 803.7 kilograms. So we just need to realize, okay, how far are these extremes from the mean? So you could just subtract the larger minus the smaller, something like that. You could find the length of the interval and divide by 2. You have so many options, but in the end, we can quickly see the difference of the midpoint, the mean from either extreme, is about 66.45 kilograms. So I can express the average weight, average weight of the cattle as being from the mean, 803.7, minus that, half the length of the interval, 66.45, to the other extreme, the mean 803.7 plus 66.45. Well, that is the messiest writing I think I have ever done. And I've done some messy writing. And so in the end, technically they're asking for what is K, so K is 66.45. But really, it's really just about finding that confidence interval. So like I said, in my opinion, these sort of questions are actually quite easy compared to other things we've done in the course. Your main task is being familiar with your GDC and just understanding what we're figuring out. And again, we are making our best guess as to what the mean of the population is within some interval and with some percentage of confidence.